In this video, we'll see an example of how to design a Turing machine for multiplication of two unary numbers. Okay, two unary numbers. So let x is equal to 2 and y is equal to 3. So what would be the output? Result is 2 into 3 is 6, right? Okay. So let's see the logic now. This is your input tape. You will have blank spaces before. Okay. I am representing 2 with 2 ones and 3 with 3 ones. So 3 ones. 2 with 2 ones. I am using a separator and 3 with 3 ones. Another separator 0. I'll tell you why we are using the next another separator between the blank space and 1. Okay. So the logic is for every one you copy 3 ones in the blank space. Okay. So for every one you copy 3 ones. So that means you will get the result, right? You will have 6 ones now. So 3 twos are 6. So 2 is your x and 3 is your y. Copy each one 3 times. Same way if it is 4 into 2. Okay, you have 4 ones. 2 ones. Now in between you have separator. For each one you copy 2 ones in the blank space. Okay, another one 2 1. The next one again 2 1. Next one again 2 1. So you will have 8 1. 4 twos are 8. So this is your logic. Let us see how you can implement it using state transition. Okay. See. So first state is Q naught. You replace the first one with blank space. Okay. First one with blank space and keep moving right. Okay. Until you find the one after the separator. In between you will have any number of ones. You put them in the self loop. Keep moving right. Then you will have a separator. Don't do anything to the separator. Keep moving right. Q2. Now you will have a 1. You replace that. See here you will have a 1. Replace that 1 with x and keep moving right. So the logic is for each one year after the separator, you replace that 1 and replace the blank space with 1. Replace another one with x. Replace another blank space with 1. Replace another one with x and replace another blank space with 1. So this is the logic. So this way you will get 3 ones at the end in place of the blank spaces. Okay, so you replace 1 with x, keep moving right until you find a blank space. In between, you will have what? One, any number of ones. You have to keep any number of ones, keep moving right. Then you will have a 0. Don't do anything to the 0, keep moving right until you find a blank space. You have a blank space now. Replace that blank space with 1 and now move left. Okay, Q5. Q5. So in between, you will have any number of ones, put them in the loop. Okay, see here we have only one, but when I have replaced all the x's, okay, you will have any number of ones in between, right? So that for that also we have to write the transition. So any number of ones, you have to keep moving left. I'll show you while we are discussing the second transition. And you will have, so let's see, for now ignore this. Okay. So you replace this blank space with 1. You move left. What do you have? You have 0. Okay. 0. Don't do anything to the 0. To keep moving left. In between you have ones, right? Any number of, so these ones. Don't do anything to the ones, just keep moving left until you find a x. When you find a x, don't do anything to the x, just move one step right and replace this with x again. So we are performing the same operation again. So what I am going to do is I am going to put this transition to Q3. Sorry, yeah, Q2 state. Sorry, Q2 state. Here only we started replacing 1 with x. So here only it starts. So you put that to the Q2 state. So what happens next? 1, you replace the 1 with x. Okay. In between, if you have any number of ones, put them in the self loop. 0 transition, move right. Then you have um, then you have a until you do this until you find a blank space. If you find a blank space, change that to 1. Okay. Change that blank space to 1 and move one step left. Okay. If you see there is a 1 in between. In the previous transition we had a 0, but here you have 1. So that 1 also you write transition. 1 tens 1, replace 1 with 1. Keep moving left. Then you have a 0. Don't do anything. Then any number of ones. Don't do anything. Okay. Until you find a x. You find a x. Move one step right. Replace this with x. Okay, and then you perform the same operation again and again. Okay, so now you have come to this part. So you have a 0 here now. Okay, then the next, where is that 0? So here 0, and you keep move one step left. So while going back, you have to replace all these x's with 1 again. Okay, you found this 0. Okay, you found this 0, and then in between, if you have 1, it will go into self loop. It doesn't have 1, then fine. So until you find a x. Okay, there is no 1, you find a x. Okay, you have to replace all the x's to 1 again to do the same operation for the second one. So you find a 0, don't do anything, move left. In between, you will have any number of x's. Replace all the x's by 1, and now keep moving left. Okay, in between you'll have a 0. Don't do anything to the 0, keep moving left. Okay, then you'll have any number of ones in between, put them in the self loop. Okay, you do this until you find a blank space and move one step. You find this blank space, move one step right, and what, replace this with 1. Okay, and do the same thing, replace all the ones. We have while coming back we have replaced all the x's by 1 again. So again replace them with x. Okay, copy this in the blank space again, 3 ones you will get. Okay, while coming back, replace all these ones with, x's with 1 again. Okay, do this until all your input strings are over. Okay, now if you are here, okay, now you are here. The next string is 0, it is not 1. So if it is 1, you will perform the same operation, all the loop, but it is 0. So when there is 0, okay, you change that to blank, move right. Okay, Q9. Now you will have ones, right? You will have 1. We have replaced all the x's with 1 again while coming back. Replace all the ones to blank space, keep moving right. And then you will have another 0. Replace that 0 with blank space and move right and accept the string. Okay, so this is how you do the multiplication of binary numbers. So if you see the whole tape is empty, you just have 6 ones. So this is your result. Okay, this is how you do multiplication of two binary numbers. You can use the same Turing machine for any numbers like 4 into 2, 5 into 10, any numbers. Thank you.